so much. We will begin our presentation. So, first, on getting set up with the Minnesota Supercomputer Institute, you need to be attached to a private primary investigator. You need to have a professor be the person who signs you up with an account. You have to go through MSI. I go through how to get that set up in the first video. I'm going to assume that if that's what you need to do, you've already done that, or you can follow those instructions there. There is a workflow to dealing with that kind of resource, however, since the way that the supercomputer runs is that it is in a second location. You submit a batch script to that second location. It runs, but it puts your code in a queue based on all of the other people at the university who are submitting code at the same time. And it has penalties and priorities based on the size of your request, based on the number of requests that you've made in the last week, because they want to avoid people who are spamming the queue the entire time. And so often what you need to do is you test a subsample of your code on your personal device, and then you work on that. Then you need to find a way to submit your code through Globus, which is a client that I go through in video 1, allowing you to transfer your code from your personal machine to the supercomputer. You use Cisco AnyConnect to then say, my laptop is going to be a University of Minnesota laptop for the next hour. I know that it's not technically a university device, but I will use the virtual portal and a VPN to simulate being a university device. And that then requires you log in using two-factor authentication, and the antivirus systems that the university uses will be covered through that process. So I also talk about installing some of the other basic script structures of writing a code for the Supercomputer Institute using Unix, because that's what the supercomputer primarily uses. There are special batches that allow you to use things in interactive mode, but that requires going on site and getting a tech consult, which you might not have. So that is to say, that's all in video 1. Now let's talk about video 2. Where is the Supercomputer Institute? It is over on the east bank of campus. It is in Walter Library, which if you have not been, is an absolute beauty. I highly recommend going there. It's a very lovely place to do work. Faculty are welcome to do it, but you need to have a connection to an account, and your investigator needs to fill out that information for you. Then, when you're writing code, let's assume that you've already now entered that project and you're already associated. You're going to write your code on your device. You're going to upload it to MSI using the Globus tool. You're going to create your proxy, so that way you can pretend that you're a university device and you can use the software that the University of Minnesota allows you to use. And going back and forth throughout all of this, you want to make sure that you have code that isn't going to break often, because this process is tedious, and you should hopefully be prepared to write your code in such a way that you don't have to repeat this process over and over again, because that is tedious and does not benefit anyone. So, some considerations for code in the MSI environment. First, it does connect to GitHub. So if instead of going through the Globus client, like I suggested in the first video, and instead you want to install a package or install some special utility using GitHub, that is possible. You will be scanned for stuff when you go through the Supercomputer Institute, because they have very high security protocol standards, because the supercomputer is a very expensive machine and they don't want you to break it. Particularly, for example, they will be making a lot of temporary files. When you're running a Stata code, for example, Stata will often make a temporary file that is a copy of your data set, so it can invert a very large matrix. But that temporary file is stored with something like a .tmp file script. So when you're running Git and you have a git ignore list for your files that you don't want to constantly be updating to Git, well, if you don't know that there are all these temporary files that are being made in the background, Git will try and still track all of those files, and then you'll end up getting an angry email saying you have reached your quota for storage for the month, or you are not allowed to upload files of this size. Go find another branch. This is to say, I don't recommend using Git. I recommend using Globus. Globus is basically like Google Cloud or Dropbox, but you have to manually press it to push each file, but it has the benefit of working with really big data sets as well. Furthermore, MSI is not unconnected from the internet. It can make all of these transfers, suggesting that if you are using a special Stata package for your work, you can do that. You can install packages from that Stata session. However, they will be deleted when you are finished, so you're going to have to upload your package every single time you run your code. This is just the nature of working with a shared virtual device. It runs on Stata version 13. We are on bigger than 13, so that means that there are some differences that I want to mention. Current versions of Stata can upload multiple data sets at once, like a normal statistical package. Stata before version 15 was kind of quirky in that it only lets you upload one file at a time, meaning that if you want to work between multiple data sets, you either need to use preserve and then upload your new data set and then work on it, save a copy, go back, merge it between the two, combine it, slice it and dice it a bunch of different ways. That is complicated and tedious. It is also your only option, because this is Stata version 13 and they have not announced any plans to update it anytime soon. So when you're writing your code, be wary of that, or consider writing a part of your script that is in R, MATLAB, or some other protocol that is more tuned to that environment. Furthermore, there are two ways that you can submit a Stata script to the MSI batch. One way is to make it so that every single line of your code has something on it. This will be a nightmare to read because it will be just a wall of text, and normally when people code, they'll have a couple blank spaces between different parts of their code so they can keep track of things, and they can leave comments for themselves. Delimiter mode does not like doing that. So instead you can add the # delimiter semicolon, and that will make it so that all of your Stata lines will be identified by the use of a semicolon instead of a carriage return, which means that you're going to have to add a semicolon to the back of all of your Stata scripts that you've already worked with. But on the plus side, it means that you don't have to type the 3 slashes to make multi-line commitments anymore. It is something that you may not be used to. I just kind of got in the habit of always using delimit semicolon on the off chance that I want to switch over to a Unix device or switch over to the Minnesota Supercomputer Institute. Anyways, again, see rule number 1. If your code works better by ignoring my advice, go for it. I'm not your dad. In terms of general options for MSI, there are a few different kinds of resources available. Namely, there's the multi-thread machines and there are the large RAM machines. Multi-thread machines are excellent for doing things like bootstrap tests, where you have a single kind of code that you want to repeat in multiple processes. Newer versions of Stata can really harness that parallel processing environment. Stata version 13 doesn't do it so easily. You might be able to make some Unix script that creates that kind of branching, and you submit each of your Stata codes under your initial seed to different cores to then run that process. This is to say it is tedious and not obvious. But that can be useful if you need to do something or something like image processing. It can be very useful because those are usually simple operations that you just need to do a lot of. The large RAM nodes are real big. They allow you to invert a real big matrix, which is great if you're using a linear approach. If you are using a maximum likelihood estimator, it might not help in the way that you would hope, because often the way that that works is based off of computing the nature of your data set and finding a residual, and that doesn't necessarily help if you have a lot of RAM to do it. It has more to do with the design of your data set in the first place. This is to say, having a terabyte of RAM won't fix all your problems. There will still be plenty of other bottlenecks in your code. Again, I recommend testing it on your personal device before submitting to MSI. Oh, another comment is that if you are switching to delimiter mode and you like to comment your code, I would recommend shying away from using the multiply, the star, and then leaving a comment, because when you're working with delimiter mode, it can't tell if you're trying to multiply something or not because it doesn't know where the start is supposed to be. This is to say it's in my recommendation, I would use the practice of divide, multiply, multiply, divide as the quotation marks around your comment. So you can have multi-line comments, and that way you won't run into as many problems. I would like to pause for a moment for questions. Seeing none in the chat, you'll love to see it. Seeing none in the room, then I will keep going. All right. So, in terms of my recommendations today for MSI batch design specifically, one thing to keep in mind, some of the resources that you will read online and on the university's website for resources are outdated. I want to tell you this in this seminar so that you know to look for it, and if you're looking for a help guide, that you know that some of these things no longer apply. We used to use a batch protocol called PBS. Now we use a thing called Slurm. So this is to say if you are looking for copies of someone else who has submitted a batch request to the Supercomputer Institute, but the code looks different because it has PBSs at the top, you are in an outdated part of the university's help guides, and you should look elsewhere. Furthermore, there are some nodes that are being retired this year and replaced. So the MSI is want to change whenever it so chooses. So if they choose to change their designs at a future date, so be it. But hopefully we will be prepared in the meantime. All right. I have found that when working with supercomputer resources, it is helpful to know a little bit of Unix. I'm not going to get into many of the power stuff, many of the complicated things, but it's useful to know if you haven't encountered it before, because there are just a couple of things that are different from working within a Windows environment. First off, you will start off in your home directory of tilde. Tilde is going to bring it to your personal directory. However, the MSI's home directory is not necessarily your home directory. So when printing the directory, it will show you MSI's home directory, followed by your PI's name, followed by your individual account. Your home directory will bring you to your account. You will not be able to necessarily see people who are from other PIs. You might have access to read files from who share your PI. So if you are collaborating with co-authors, that is a possibility, but you need to talk to MSI to get that set up. In terms of listing your files, same as Stata, ls lists your files, ls-l is long list, and it will list your names of resources as well as the date that they've been modified, their file size, permissions, etc. If you want to change directories, you use the // to go to a directory down one, and then the name of your directory to get to the next step. If you want to go up and over, as I've demonstrated in CDY, you can start in your first directory, do a double dot to go back one, and then define Y, and that will bring you across one directory. Keeping track of your directories in MSI is not intuitive because it's all through a terminal, but that's what you got to deal with. In terms of Unix comments, you use the pound sign. So you love to comment. Make sure that you keep your comment clear to what project you're working on, clear to the timing that it applies to. So that way, if you have to change your mind later, you know where it came from and what to do with it. You may remove files with the rm command. rm-r is recursive remove, which is the specification for removing an entire folder. So if you've accidentally made a folder that was a copy of something or an outdated version, you'll need that specification. Move is mv. You go from location 1 to location 2. So in this version, I started in x/my file, and I'm going up 1 over to y, and then back over to save it in this new location. This is also how you can rename files. So I've noted here that in my 6th line, that I have move my file into my file2.txt. That is how you rename it, is you just say, oh, I'm moving this file, and in the process of moving it to the same location that it already is, I'm giving it this new name. CP is a copy, mkdir is make directory, shift insert is your paste, not control C and control V. Shift insert is how you paste things. So if you need to insert a little piece of code or a password or something like that, shift insert is the way to go. All right. If you want to leave a message for yourself, you want to echo the terminal, or you want to leave print a string, you use the echo command. But there are also ways to store it. So the greater than sign is supposed to be like a little arrow. And if you do greater than sign, store your file in a certain location, you can then take a thing that you print and store it in a file for later. Great for making log files. So if you have a specification or a version of your code that you want to keep track of, then save it to a file, and that way you'll have it for later. And when you go back to your Globus client, you can then pull that file later and bring it to your personal device, even if you were working on a script that was generated within the supercomputer environment. If you use two greater than symbols, that's going to update or append. So if you want to continue adding on to a file that you've already created, you use the double sign, the double greater than sign, to be a double arrow. If you only use the single arrow, it will replace the file of that name that was there beforehand. So single arrow is replace or create, double arrow is append. There's also the print command, and print is goofy, but it's very flexible, but it's also very picky. I mention it here just to have an example that you can refer to later if you want to refer to this video that we are recording. What I'm doing here is I'm saying print f, which is saying, all right, take this thing that I'm about to print from the terminal. /n is to then say, all right, have a new line, and I want you to make this a string. Hello world is the string that I am including, and then going into my file is then all at once to say, take this thing that I'm about to say, hello world, take that string, move it over to this file, save a copy of it for later. Yeah. Macros and globals. So if you have something in a Unix script that you want to save, you just use the equals sign. So if I have a variable and I want to assign it the number 1, myvar equals 1. Or if I want it to be a string, myvar quotation marks 1. I can also do that with the specification that I just gave on the other page, where I use the print command. Now what I've done in this case is I have wrapped that print command with a $sign and parentheses. That is another way to say, hey, I'm about to do some Unix commands, and I want you to take the output of that Unix command and pretend that that output is the input I'm about to give you. And so you then say, all right, we have this expression. In this case, I had myvar is equal to 1 from my first bullet point. In my second point, I say, all right, well, take myvar and add the number 3. Then expr is to say expression, so it's an expression operator in Unix. I'm storing that because I had to wrap it in parentheses and a $sign, plug that back in and say, all right, print that number that I just told you. It works kind of from right to left instead of from left to right. Unix is weird. Again, I'm not spending a lot of time on this here for the sake of detail. I'm trying to just give you an idea of what kinds of things you want to look for. And if you're seeing someone else's code, you can at least say, okay, I think I see what they're doing here. There are some base commands like date and print working directory, which can be helpful, again, if you're making a log file, because you might want to check whether or not your Stata script successfully switched from one directory to another, whether or not you are executing your script from your home directory or from home directory / second year paper / draft 3. Moving on. Cat. If you want to peek at the contents of a file, the cat command will show you the first few lines of it. This can be great if you want to see if you successfully downloaded a file without opening the whole thing, especially if you have a big file. Cat is useful to just peek on your file contents. Tac is cat backwards. Get it? Anyways, Unix programmers think they're very funny, and that's how you can look at the end of a file. So if you've just appended something and you want to see if your append was successful, you can use the tac command, and it will show you the bottom few rows or the bottom few bits of your file. All right, within a terminal, when you are loading something like Stata or MATLAB, you do that with the command module load. Since you can't click on the thing and you can't specify the directory that you would normally store Stata in, and because the supercomputer doesn't want to give you permission to even access those files, they've created this thing called module load, and it will do that loading for you. you include that in your script. I have an example in part 1 of this video. This is just to say that module is the Unix way of then beginning to load your Stata or MATLAB script. Just make sure that when you're doing that, you are loading that module while your working directory at the time of loading it is the directory that you wanted it to be. Make sure that you check this. Furthermore, since this is a Unix device, remember that spaces are weird. If you're working with a Windows device, you can have spaces in your directory names and it can handle it pretty well. If you're dealing with Unix, you have to be careful about slashes going in one direction versus another. R, for example, likes to have backslashes instead of forward slashes, which can be interpreted as an escape character, which is a way of saying, I'm done specifying my string. And so if you have a folder name like my space projects, and for some reason you're getting the error message, I'm just getting change directory to my, but no projects. Why is that? The answer might be the way that Unix is handling that escape character when it sees a space and it thinks that you're done, or the backwards slash. Okay. Nano. Nano is a way that you can open a file in a text editor. So it's kind of like opening the file in terminal. If you ever had like a text adventure game when you were growing up as a kid, maybe I'm just showing my age, but doing everything within a terminal and you were just getting the text scripts of things, that can be great for our code. If you're writing something that's just like a text file, if you're dealing with like a data file, that's going to have a bunch of wrappers that are not going to be easy to read in Nano, but you technically could open it. Nano is going to be great for either changing small specifications of your code without taking your file, downloading it back onto your personal machine, making the change, reloading it back up to the personal machine, all of that stuff. If you just want to change one thing, like a seed value for your random number generator, or version 3 of a file instead of version 2, Nano is a quick way to do that. It will update as your date modified metadata as well. Moving along. I mentioned earlier the spaces. Be careful when you are specifying. If you are inputting an argument that expects a single thing, but there are spaces in between it, be mindful of this. But that's not really going to matter for basic commands. That's more going to be the advanced thing, which I can talk about later if there is further interest. What I'd really like to get to is some of the other best practices to consider that aren't things that are particularly complicated, but just like things to think about while you're working with this data set. First off, folder names and file paths can get very long. That's a good thing. It allows you to get as nitty-gritty and specific as you want with your folder structures. Don't be afraid of giving something a very detailed folder name because there are going to be 5 versions of my paper or DID paper or minimum wage paper. You're going to have more than one of those. And so you'll maybe want to specify it by giving it a unique name, giving it maybe a start date in the folder name, specifying if it's particularly for a class or for a project in particular, you name the project in that folder as well, and the folder within the folder. There's so much space for you to use in descriptive file names, and that is to say, there is, please don't ever just list a file as some generic name, because especially if you're working with collaborators, they don't know which version that's talking about. And furthermore, you can very easily fall into the trap of final, no wait, final 2, final post midnight, final parentheses PI edits, wait, actually final, no, wait, conference version. Just use the date. The date is great because chronological time is going in one direction, and if you just include the timestamp as the instead of versions or instead of names, then you can just refer back to a notebook and say, hey, by the way, for conference, I'm using the version that came from January 1st, 2024 versus the version that came from January 2nd, 2024. And everyone gets on the same page. One thing to be mindful of is that especially if you're working with Stata and working with Unix at the same time, that they play by different rules for naming things. So particularly if you want to use underscores in your directory name, or really any symbols in your directory name, that's usually a bad idea. Avoid them if you can. Sometimes you can't get around it, but for example, the $ and the tilde sign are used by Windows to specify a temporary file. Underscores are used in Stata for temporary variables and temporary file locations. And if you include that as one location for a file and then you refer to it in your code, there's a chance that it won't know which protocol you're referring to, and you're just going to make things more complicated, which you can avoid by just using a different letter or number or what have you. Furthermore, when coming to Stata, Stata can handle up to 32-character string variable names. Again, you can be pretty descriptive, which is great, but it can sometimes cut you just one letter short for something that seems like an intuitive name for something, which is where you would want to instead switch to things like a variable label or the notes command. I didn't know that that was a thing when I started. You can type notes and have your variable name, and you can leave just text notes for yourself about that variable without the limitations of a label. And you can then include the timestamp in which you've created that variable if it's user generated, or you can include a more detailed descriptions. You can include more than one note on the same variable, whereas you can only have one label of your variable at a time. Notes are great, highly recommend for Stata. Furthermore, keeping this in mind, that if you're using a package, sometimes packages will make temporary variables that are based off of your current names, and if they do something like adding a 1 to the end of it, then all of a sudden, if you had a 32-character long name and it needs to add one more letter, now it's a 33 and it'll break, and then you've just wasted a week of time coding and waiting for your queue to run, and then it runs and then it doesn't actually run. All of this is to say there are ways around this. One way to do it is by using temp variables or temp vars. Basically what Stata does is it will say, all right, I'm going to give you a local that you define. So if I have something like temp var my variable, all one word. And Stata will then say, all right, I'm going to take that and use it as a local, and you will be able to treat it like a local, and you can then refer to it and make it as long as of a name as you would like, but technically actually it's called __00000A. And it will just use that in all of your regressions and coding, which again can be helpful, but you need to be mindful that that means that you can't use underscores necessarily in the naming of that temp var. Okay. Ways to deal with errors. One approach. If you are writing code and you are running into errors because the environment or the package that you used didn't update the way that you hoped it would, or you forgot to upload it, or errors happen when you're coding, what do you do about it? How can you philosophically approach this to get your project finished? One approach is design your code with the expectation that if something goes wrong, it will stop and you will just prepare for enough time for you to fix the problem and readdress it and start anew. That can be helpful because it shows you exactly where the problem is. There is the no stop suffix, which can be helpful for a do script if you want it to keep running. The issue with that is that if you intend a portion of your code to do something important, like generate a new variable or change the name of something, and then it just keeps on running, you can't necessarily identify where that error message came from. It becomes tedious, and if you have other code later on that then expects you to collapse or delete or condition on data, then you won't. It will continue to try to run that code even though it shouldn't. Capture is a useful code for saying, all right, for this next command, I want you to really make sure that you run this regardless of whether or not it's actually going to work or not. The downside is that when you run capture, it will also then not show you what it's doing. It will hide that result, but you can link capture with something like capture noise. It shows you the inputs that it is using rather than just running a regression, creating the storage results, but then not showing you what they are. Another way, which I've become very fond of, is to use if triggers. Rather, if you have an old portion of your code that you don't want to worry about anymore, I often see students wrap it in comments and say, yeah, I'll keep a copy of this for later. And if I want to go back to it, I'll just uncomment it and it will all be fine. Remember, again, that the version of Stata that you're going to be using is older. The Unix script works a little bit differently, and sometimes I get escape characters in the middle of my comments in a way that you want to avoid. What I instead like to do instead is to use an if trigger and just say, if 1 equals 2, then do the following code. That way I can still track where the parentheses are in my code, I can track where things are going, and 1 doesn't equal 2, so it will skip that section. And if I want to change it, I can just change it back later, or I can define a local to say, all right, run code 123a equal to 0 or 1 and use it that way. That is helpful because it is more functional than using comment to ignore parts of your code. And it still lets you keep that code in place if you want to avoid deleting it and making a copy of your file, but it's not going to run into the same errors. Okay. Shell. There's a command within Stata that lets you kind of go back and forth between Unix and Stata, which is especially helpful when you're on the supercomputer because it is a Unix device. The shell command lets you kind of emulate a set of Unix commands. That's a whole other video as to what you can do with that, but just knowing that it is an option that is available to you. File open is a Stata command that lets you temporarily open a file, not like a whole data set, because again, we're working with Stata version 13 here, so we can only handle 1 data set at a time. But if, for example, you want to open a text file and pull the name of a variable from the first line of that text file, and you can do that with file open. I've used this to make log counters, so that way when I update something to my GitHub, I have a version of that automatically increments every time I run the code, and it just gives me my timestamps, and I can read that out in my log file, and then I can store that as a global or as a scalar in Stata, and even incorporate that into my Stata log file, even though it's coming from the Unix level. Remember that Stata and Unix have different ways of referring to strings. Stata has like 5 different ways of storing a string character. Sometimes it will want you to do the triple quotation marks instead of the double quotation marks. On the other hand, Unix can use just single quotation marks, but it's not the sideways one. I highly recommend using set trace on if you are having trouble identifying whether or not your string is actually a string, because sometimes the way that things get wrapped up can be confusing. I do not recommend passing a lot of that kind of string architecture between Stata and Unix if you can avoid it, just because sometimes Unix will think that you're giving an escape character and it will stop running. But this will be something for you to test when you are going through your own code. Exit is going to be how you finish a Stata session. You'll want it at the end of your Stata scripts in the supercomputer. Otherwise, it will just stay open and keep your resources running that entire time, and it might not finish closing your log file or doing a lot of other cleanup operations. I recommend exiting and clearing. Also, this is a shared resource. I'm a public economist. Don't have negative externalities on others. When you're done using a resource, we all have to share this space and move on when you are finished. And DI new line is useful for making log files. You can enter a number and it will just skip that number of lines. So if you want to print out a bunch of regressions, but you don't want the results to all be stuck right next to each other, it's a way to clean things up a bit. Set trace. Set trace is the way to debug your code by going to the most narrow version of it, and Stata will show you all of the things that are happening within your code. There are different levels of it. It goes from 1 to 6. 6 is the most in-depth. When you just set trace on, 6 is the default. If you want to go up a level, and it will, instead of showing you every level of the code that's running, it will kind of wrap some of them up into more general versions. You can use set trace level 1 to say, all right, only show me 1 level deep of functions within functions. That can be helpful if you find your log files are becoming gargantuan and you need to just trim it down a little bit. Set trace 1 or set trace 2 is usually sufficient to realize that, oh, I forgot to put a closed parentheses in my equation. Sleep is a timer to just stop and not do a thing for a second. This can be helpful if you want to make a script and you want to, for example, show a graph that you're making, and you just want to check to make sure that it ran correctly, and you want it to be there for like a second, so you can just peek in on it and then have it close and then move on to the next thing. That's useful, that's great. You probably don't need to use it on the supercomputer, but when you're debugging your code, if you want to simulate something, it can be a neat little command. Pause is another code that's helpful for debugging on your device. If you have a code that's going to take 3 hours to run, but you have to go to class, but you also want it to wait halfway through running so you can check to see if a certain variable was made to your specifications, but you don't want it to drop all of the locals that you're working with because you're running within a for loop or something, wouldn't it be great if you could just say, hey, use this as a stopping point to pause the code for a moment so I can check in on it, maybe run another command, run describe, run summarize, and then go back to my code and complete the for loop? Great, pause on. Pause on sets this command and turns it on or off. After you set pause on, every time that you run the word pause in your Stata script, it will give you the opportunity to check in. You press Q, enter to continue going. You press break to say, hey, I found a bug. I'm just gonna etch a sketch, start from scratch, and abandon the loop that I'm running right now. I don't recommend using pause on the supercomputer because, again, if this is a batch script, then it might run at 1 a.m. and it's going to just wait for you to press Q on it and you're not going to be there. So it's not going to be useful in that regard. But if you're running test code on your personal device, it can be a useful trick. Tracking your results. We have your regression results. I'm going to skip some of these because some of them you'll encounter in other contexts. MSI makes its own log files, but you should know that the log files that it will run are just about the MSI related code. So if you're running Stata code and you've assigned the MSI script to create a log file, that might just give it its supercomputer log file. It won't give you a Stata log file. You'll want to create a separate part of your Stata script with a Stata log file with an SMCL that you can then find later. I'm gonna get, I mentioned this point earlier, but I will reiterate. Sometimes when Stata is working with temporary files, it will create a TMP file. TMP file gets deleted when you are finished. It is the way that Stata likes to invert a large matrix. This is to say that when you are requesting resources from the Supercomputer Institute, account for that. So think about the file of the size that you need, plus a backup, plus enough space to then invert that matrix, plus maybe another copy if you want to have an old version versus the new version that has your adjusted modified variables. So I usually say 4 or 5 times the size of your base file is what you want to prepare for. Fortunately, the supercomputer lets you request 5 terabytes of storage and 1 terabyte of RAM, but you do need to send in a request to the Supercomputer Institute saying, this is how I got to that number, and so that's a good way to justify it. Jumping ahead, I mentioned earlier, when creating a log file, sometimes it is easiest to just name something based off of the time rather than trying to keep track of version 1, version 3, final version, etc. So I have a code script here, which again, you can go back into in the recording after this if you don't want to write it down now. The point simply being that there are ways to write a Stata script that will take the current timestamp, save it as a text string, convert it into a format that makes it easy to follow, and then you can just make that the name of your file. If you do so, the best practice that I would recommend is naming your file year first, then month, then day. Again, I will be showing my age here. Y2K was a phenomenon that happened in 1999 to 2000. There were a bunch of coders who were trying to store file names and values using 2 digits. And when 1999, you store that as 99, but then when 2000 was coming along, they had to prepare for how these systems would manage going to 00. And so if you're trying to sort your files and you've sorted 100 or 0 before 99, but if you just write the file, my file 1 well, 1 will actually show up before 9, but if it's 10, it'll show up after 9. But if it's 99, then alphabetical order is in Unix, and if you don't have leading zeros, that will complicate things. And if you switch month and day, that will complicate things. And if you go based off of day, month, year, that will not put things in chronological order. The point of this slide is just to recommend the best practice of starting with the largest level of specification, then go down a level, then go down another level, then go down another level. Okay. Sometimes you're working with a very large file, so large that if you try to open it on your computer, it will crash. So how do you know that you can write code that lets you work on the file when you get to the supercomputer if you can't check the file that you're wanting to work on? Option 1 is hopefully the person who provided you with your data set gave you a really good instruction manual. But sometimes that's not the case. And sometimes Stata deals with capital letters different than your personal operating system. So you need to be mindful of this. Is there a way for you to check in on your files without necessarily opening the whole thing and crashing your device? Yes, here are some ways. First, the describe function in Stata doesn't require that you open the whole file. It will just look at the metadata of the files that you've included. So that can be useful if you want to check if the storage variable is date with capital D or a lowercase d. And that way, when you then import those values later on, or if you want to save a subsample, you can know the way that Stata is currently storing that term. Another way to do it is to load the whole thing, use my file x.dta, create a subsample, so that way I can save a smaller version of the dataset onto my computer. And I'll say something like subsample 01, and that's a special command. That would be a second line here. I'm doing in the interest of time. This is the first line. This is the second line. And then I have a copy of my file too. That's 1% of my original data set, and I work on that to make sure that my code runs correctly, and then I submit it to the supercomputer later. The problem with that is that it requires that I'm able to open the file first. But you can specify your use command in a way that avoids this. So if I say use everything, there is an implicit blank space after the word use. If I wanted to load particular variables, I would say use minimum wage one space year space revenue space. You can also use the in command to say, I want you to give me line 1 versus line 2 versus line 3. Or you can use the if command to specify certain conditions that are met based off of your terms. But those terms don't have to be variables. Those terms can be random things or other Stata commands. So if, for example, you say use all of the terms if this uniform variable randomly set is less than 1%, using the file my file data, what that line will do is it will evaluate each of the lines one at a time in your Stata file, and if that random number generator is satisfied by being less than 1%, then it will store it in your new file, my file, and then you can have a copy without opening the original file. You can also use the head command, but that will only give you a handful of observations, like 6 or 10, but not enough to run a sample regression off of. So when I was working on my second year paper and I had 400 million observations and I wanted to just get a couple thousand so I could just run a regression to see if it worked, I used the third option, use if are uniform. And that worked fine for me. All right, file size. There are some commands in Stata that will make generous assumptions on you without telling you. Particularly, there is the file storage commands that will create values in ways that you didn't specify. So my first line is to say, all right, if you want to specify a file type, you can do this while you are in the middle of generating it. So generate variable 1 equals 0 will generate a new variable. It's going to be whatever format is the default. But if you specify byte, then it will specify that this is a byte versus a float stored in scientific notation versus a date versus a string. Compress can be a useful tool after the fact to convert your files to the smallest possible version of them. So for example, if you have a bunch of string variables and you've given it enough space for a 32 character long string, but you're only using 16, then compress can take a look at all of the values stored in that variable, cut the extra fat, and cut down on your file size, perhaps making it easier for you to work with. I came into a problem with compress once that I want to share, again, in the interest of being a best practice. I was loading my file based off of different data sets. I was using Dun & Bradstreet data, and the way that it was stored at the library was each year had its own file. So then I had to open each file, and then I added some of my terms in Stata, and then I was going to stitch them after that. I ran the compress command so that I could have a sample of one of the years that I just saved on my computer to look at. And when I ran compress, what happened was Stata looked at the variable called year, and since it was broken up by years, it only looked at 2015, and it said, all right, well, all of the variables in this column are 2015. So instead of keeping it as a number, I'm going to convert it to a byte, and I'm going to give it the label 2015, and these are all just going to be stored as ones now. And so I've lost the ability to use 2015 as a number, and then when I stitched 2014 to the end of that file, it did the same thing, but it made 2014 the label, but it still only used the value 1 for the entire column of years. This is to say that I lost data by doing the compress command. If you're going to do that, you can compress one variable at a time and avoid doing this, or you want to consider your order of operations when you are coding and that you want to stitch everything together to make sure that there's at least some variation in your terms before you run the compress command. And you should double check for that, because if you get that error message, that might be the reason why. In terms of speed of running a regression, you don't have to create a new variable every time you want to create an interaction. You can use a single pound sign to create an interaction, or a double pound sign between terms if you're going to create the interaction and also include the original terms. I've used the C here to specify that the variable that I'm using in Stata is a constant or a continuous variable. You have an I for using a categorical variable. Some packages and some Stata commands will prefer one versus the other. This will run faster than creating a new variable called myVariables². However, there are some packages that don't know how to deal with that. So, for example, I've been using the Gelbach decomposition, which was developed in 2016. And when I try and include interaction terms like that, it just doesn't know how to work with it. It doesn't know how to run, because it was a user-defined package, and it's doing great econometric things in other regards, but it's just not robust enough to handle that concern. So this is to say, if you can avoid making a squared term manually, I recommend doing so, but sometimes that's not an option. Last slide. All right. Coding and stability. The couple of tricks here that I will mention. First, if you want to learn the levels of a variable that is included, so that maybe you can write a for loop about it later, the levels of command in Stata is a way to do that. That will store each of the unique values of your Stata variable, and it will store it as a big string that you can then loop through later. That's great for using like states or something without having to recode it. However, that can also be slow. You could use the egen command and use the by sort prefix, which will say for each of the versions of X, for each of the unique values of X, do the following special generation and use an egen function to do what you want to accomplish. That will be a bit faster. You can define your own program and run things, and you input some result and you use your program instead of a for loop. I recommend doing this whenever you can. It's a little bit tedious to use the program syntax in Stata, but the reason why I think it is easier to work with is because it is tempting to write a for loop within a for loop within a for loop within a for loop, and if you have one parenthesis that is off somewhere, you don't necessarily easily can tell where it is. And if you think it is where it is, or if it's being wrapped and hidden by a comment or by a quotation mark, if you have a program that you define and you instead run a for loop and you just implement that program, you only have one line of code that you need to check, even if there is stuff happening within that program, but it reduces the number of things that you need to check. Yes, you can accomplish the same things. Refer to rule number 1. If your code works, then it works. But I recommend learning the functional syntax to define your own programs because it gives you fewer things that can break. One minor difference, if you're going to try and cut down on a data set, let's say you're using the current population survey and you want to create state averages of the number of people who are employed at different wage levels. So you can run a regression about a minimum wage or something. One way of doing that is to use the egen command. The benefit of that is that it will allow you to keep all of your data, and then you can use the by function to say, all right, so for each minimum wage level, for each county, for each year, for each however you want to buy that, you can use the by prefix to do that. However, it doesn't work with weights. However, you use the collapse command, it does. So collapse can be useful if you want to preserve your weights. You can then say, all right, I'm going to specify collapse this data set by state, by year, by whatever that same term would have been, but I want you to use sample weights or frequency weights in a way that egen didn't let you use. It is quite a bit slower to then use like preserve and collapse, and so that will be difficult when testing it on your personal device. But if that's the only option that gets you where you need to go, then so be it. All right, do I have any final points? One last point, yes. Sometimes you will want to make globals and locals. The difference between a global and a local in Stata is a global is a temporary variable term that you can keep when your session is done running its code. A local will get erased as soon as you are finished. Locals are also very picky. They make things easy to run within for loops, but they don't like working within functions the same way. Yesterday, I was writing a code where I was making a graph, and I was trying to define the color red, the hue that I wanted to use. I defined that at the start of my code and then ran my file, but it didn't recognize the local when it was within the functional form. So I had to move my specification of red into the function itself. That's goofy, but when I ran it as a global, I didn't have to make this specification. They should work the same, but they don't. Also, if you want to do for loops within for loops or run a regression of a function within something that then compounds on itself, global has the curly Q brackets that let you lock where the name of your term begins and ends, and you can have a local inside a global, so you can have these curly Qs over the local brackets, but you can't have it the other way around. So that is a thing to consider when defining all of your terms. And then I was going to go into awk, grep, and sed, but that's all just some Unix nonsense that we don't need to deal with today, because the main moral of the story is that when dealing with the supercomputer, there are some practices that might be a little different than the way that you're used to dealing with Stata as a tool. You're dealing with an older device when you deal with the supercomputer, but if you need to deal with 400 million observations in an unbalanced panel, it's the easiest way to do that. All right. Are there any other questions? Delightful.